Let's have another look at the index view for the listing of products. In the last column here, we've got 3 A tags which define links for actions that we can take. Each link uses 2 tag helpers, one for the action name and the other for the route ID parameter, which is the ID for the product model object in that row. We're trying to define an action called details, so let's create a view file called details.cshtml. I'll paste in all of the contents for this file now, and let's have a look. This is using the product model as the model directive at the top, and it's just a single instance rather than an IEnumerable. We've seen how the title gets set, and then there's some markup to show the product details. It's using the DL, DT, and DD HTML elements, which are a description list with terms and definitions. Then we're using the display name for and display for HTML helpers on the various properties for the model. Finally, at the bottom, we're using some A tags with tag helpers to create links that we can use to either edit the product or go back to the list. Now that we've got the view defined, let's get an action added to the controller. We'll define a public method that'll return an iAction result and call it details, so it'll match up with that view we just created. It'll have an input parameter of int called ID. Inside the method, we need to find the product with the past ID. I'll use a C# link query. Link is language integrated query, and the find query. The p value here is an item in the products list property, and I'll look for one that has an ID that's equal to the past ID to our method. I'll return something based on the condition of whether the product variable we just assigned is null or not, meaning whether we found a product based on that past ID. If we didn't find one, I'll return not found, and otherwise, I'll return a view and pass the product we found. So now let's run it and see if this details view works. Here's the product page, and if I click the details on the first row, it works. It's not a very fancy page to be sure, but it looks okay. And if you are curious about what those HTML helpers are actually rendering to the browser, let's inspect this page just a bit. There's the DD element, and the display for just puts the value of the name property into the final HTML. Pretty slick. Even the description just has the content of the description property as the output. I'll go back to the list, pick a different product, and try it. It works too, and this is great. And if I change the ID in the browser address to 7 and hit enter, we get a 404, just like we intended. This app is really starting to come around. But hard-coding our products is not a recipe for long-term success. We're going to get a database defined so we can get our products in there and complete the functionality to edit the products. Now we're taking the step of adding a database to our app. This is an important step in almost every application, and there are lots of different approaches in databases. We're going to get to the code very quickly, but a little introduction to the approach we'll be taking here is a good idea. Since we don't already have a database waiting for us to connect to, we'll use Entity Framework Core, sometimes just referred to as EF Core, or even just EF. It's an open source ORM maintained by Microsoft and the community. ORM is Object Relational Mapper, and if you used Hibernate in Java or Active Record in Ruby on Rails, you'll be familiar with the concept. We'll define simple classes to represent objects that we'll store on a table, like a class for product, and then the collection of tables and schemas are managed by a class called a DB context. We'll create migrations to apply or reverse schema changes to the database. And you might be wondering which database platform we'll use. EF Core supports many different providers, to use its word, but we'll use SQLite to keep things very simple. No extra installation of a database platform like SQL Server or Postgres or MySQL here. Those platforms have great support in EF as well and are more appropriate for production applications, but SQLite is going to do everything we need and more. What you'll see here will definitely get you started with databases and EF Core, but this is an area where there is lots more to know, and the official docs are a great source, and the Pluralsight courses on Entity Framework by Julie Lerman are what will really go into more depth on this topic. But now, let's dive in and start working the code. As we get started with the code, I once again want to point out the README. We'll be using EF Core here, like I said, and there's a little section on some of the key topics of interest right here. Feel free to head over there to see more details on anything you're going to see here. To get started, let's create a new folder called Data in the root of the project, and then I'll create a file called product.cs that we'll use to represent a product we want to store in the database. I'll give this class a namespace based on the folder again, so carvedrock.admin.data. Then I'll add the class declaration, and finally, I'll paste in the properties. So at this point, there's nothing special about this class at all, but it'll represent a table in our database, and each row will have the columns you see here as properties. Now let's create a file for our dbContext class. The name doesn't matter, but I'll call it productcontext.cs. I'll add the namespace qualifier again and provide the class declaration. This class is going to inherit from an EF class called dbContext. And what you see when you try to do the little light bulb here is that it's wanting us to create a new class to define dbContext. VS Code doesn't know what a dbContext is. That's because EF Core is contained in a NuGet package that wasn't included by default in our project. Control backtick brings up a terminal window in VS Code where we can add the EF Core package. Since we'll be using the SQLite provider, I can simply take the dependency on that package, which will include the lower level EF Core packages we need too. To take a dependency on a NuGet package, you can use the .NET add package command from the CLI. I'll paste in the command, and the package that we want is Microsoft.EnityFrameworkCore.SQLite. When I run it, I get an error. The red text is telling me my mistake. We need to run the command in the directory where the csproj file lives. I'll clear this, and then change into that carvedrock.admin directory and run the same command again. It worked fine, and if you're curious about what just happened, the package itself was downloaded locally, and the csproj file was updated to include the reference. Adding a package in this way will add a package reference to the csproj file. That's why we had to be in the directory where that file is. And now, back in our product context file, we can resolve the issue on the dbContext. It's now suggesting the additional using statement for Microsoft.EFCore. To define a table containing products in this context, we can create a new generic dbSet property of type product and give it a plural name for the table, and it'll be a set of type product. Then I'm going to paste in a couple of lines that'll define where our SQLite database will live. There's a new string property called dbPath that will be the fully pathed file name for our database. I set it in the constructor, and I get the special local AppData folder, and then add a file name of carved-rock.db. Then I provide an override for the onConfiguring method of the base dbContext class, and I'm saying that we should use SQLite and point it at the path we just set. I just realized that I used the wrong name for the class definition. Should just be product context, not product dbContext. Now we need to define what's called a migration so that we can get a table of products created. Let's go back to the terminal, and from the same directory where the csproj file is, we can create our first migration. To do that, you need to have the global EF tool installed for the .NET CLI. Do that with this command. Then we can run .NET EF migrations add to add a migration, and we need to provide a name for us to refer to this migration. I'll just call it initial, since it's our first one. Adding a migration will build your project, so if there are errors in it, you'll need to fix those. And it also requires one additional NuGet package, efcore.design. Let's add that with the .NET add package command. That works, and I'll clear the screen again. Now we should be able to add that migration. And it worked. This created a new folder for us, called Migrations. It created that folder by default, and you can use other args to change this. But inside that folder is the logic for the migration. The file name is the date, and then the name we chose. And if we have a look at that, it's got methods for up and down. Up creates the table for the products. The code you're seeing here is provider specific, so this is logic that works with SQLite. If you were using a different provider and created a migration, this code is going to look a little different. The down method drops the table. This is what would happen if we applied the migration and then wanted to undo it or roll it back. In the next clip, Let's run the migration and have a look at the new database. If you've created some EF migrations for a project in a database, the next step is figuring out how you actually want to apply those migrations. We've got an initial migration defined, so let's apply it in the simplest way possible, from the command line. To apply a migration, you can use the .NET EF Database Update command. This will apply any migrations that haven't already been applied. Once again, you can see that this command actually builds our project as well, so definitely make sure to keep your project in a buildable state. And then it's done. That was easy. To see what just happened, we actually need to look at the file system since that's where the database was created. More specifically, that local app data folder that we referred to in our product context class. I'm on a Windows machine, and here's the app data local folder for my user account. On a Mac, it's users.username.local/share. Inside that folder, there should now be a Carved Rock DB file. This file is the SQLite database that was created by our migration. And to query around here, let's use a VS Code extension. I've already got it installed within my VS Code instance, and it's the one called SQLite. The extension page has some info on how to use it, but it's pretty straightforward. I'll hit Ctrl-Shift-P to bring up the command palette, and then I can choose the SQLite Open Database command. That lets me choose a database from a file, and I'll choose that Carved Rock DB file we saw in the local app data folder. That adds a SQLite Explorer section to my folder view, and it's showing two tables, Products and _EF Migrations History. Let's look at the Migration History table. Just hit the little play icon here to query for all rows. It lists our migration in the table and the EF Core version we used. This is a record that shows that our initial migration has been applied to this database, so it won't try to apply this one again if we just ran that same update database command right now. And if we look at the products table, it not surprisingly doesn't have any rows. For this application, I want to set up some test data that'll be the same whenever we start the application, and such that it can create and update the database on the fly to avoid the need to run the CLI command. So I'll delete this database file for now, and we'll see another technique for applying migrations and getting some data created in the next clip.